good morning, everyone. Now, I'm going to talk to you about open sourcing Miranda. And first I have to find my slides. So I press share screen. Here they are. Share. Can everyone see them? Oh, well, I can't hear you, but I guess you can see them. Right. So what is Miranda? Let's start with that. Oh, why wouldn't it move? Ah, it did then. Sorry. Yeah, Miranda is a lazy, polymorphic, purely functional language, which I designed in the 1980s. First release was in 1985, and there were releases in 1987 and 1989. It was the first language of its type to be widely used. It ran at hundreds of sites, and it was really the main precursor of Haskell, to which it has many similarities, although Miranda is a smaller and simpler language. Miranda was closed source, distributed under a proprietary license, which is why it got quite easily replaced by Haskell, because Haskell was free and open source from the beginning. Miranda was also 32-bit code. 64-bit computers hadn't been thought of in 1985, or probably been thought of, but they weren't there yet. And Miranda was implemented by an unusual method. It's a lambda calculus-based language. The lambda expressions are translated to SK combinators, which are then executed by a virtual machine that does combinator graph reduction, normal order graph reduction. Now, during the last year, I have made it open source. Well, changing the license isn't very difficult. I chose a BSD license, same as Haskell. Making it 64-bit was the more interesting and challenging part. And the idea of doing this is it's a historical record, so people can see what was in Miranda, and I hope it may still be useful to some people. Particular thanks are due to Richard Carlson, without whom I would never have undertaken this project. He spent several years persuading me that it was worthwhile to open source Miranda, and I'm also grateful to him and to Bodil Stokey, Stuart Clayman, Richard Bornat, and others for advice, encouragement, and testing versions of open source Miranda on different platforms for me. Originally developed under BSD Unix, Miranda runs on Linux and other Unix-like platforms, MacOS, Sunos, etc. The pressure to convert it to 64 bits arose because MacOS, from MacOS Catalina onwards, simply won't run 32-bit apps. So I've been run over by reality. A Microsoft Windows subsystem for Linux, which is also an important target, also won't run 32-bit apps. I think that might be changing with Weasel 2, but the world is moving to 64 bits, and so must I. Right, converting the software, this 30-year-old software, from 32 bits to 64 bits was not at all straightforward. Making the license open source was the easy part. So I did it in two stages. First, I converted this 30-year-old C code to the modern C standard, which turned out to be quite a lot of work. And only then did I undertake to change it from 32 bits to 64 bits. And that proved actually quite easy once I had it conforming to the 2011 C standard. So I'm first going to describe how I managed to do that, to make the change. And then at the end, I will discuss my future plans for Miranda, now it is alive again. So let's have a quick look at what the old C language was like. The first published standard for C was Kernighan and Ritchie, 1978, and that was the standard to which I wrote the Miranda code. It was about 2 years' work when I originally wrote it. Here's a little sample of Kernighan and Ritchie C. It doesn't do anything useful, it's just for demonstration purposes. We have three functions, fun, foo, and bar. None of them have their return type declared. That's because they're all int, and Kernighan and Ritchie C had an implicit int rule. If a function was int returning, you didn't need to declare its type. And notice that fun calls foo and bar, whose definitions haven't been seen yet, they're further down the code, but that's okay. It can assume they're ints because no forward declaration has been given, so there must be int, and whatever is given for the parameters must be correct, because there was no actual formal parameter correspondence type checking in Kernighan and Ritchie C. So you could play horrible tricks. In fact, people had other tools. There was a tool called lint that you could use to do the type checking. And of course, I used lint heavily when developing Miranda. Notice that there's no type void in Kernighan and Ritchie C. So bar doesn't actually return a value, but it still counts as an int function. And if you were foolish enough to assign its value to something, you would just get some rubbish integer. So quite a dangerous language, really. Close to the machine, you could think of it as a kind of high-level assembler. So what was good about this is it allows mutual recursion without any forward declarations, provided your functions are all of type int. And I'm going to explain in a moment why my functions were all of type int. So functions in different files could call each other freely. Again, as long as they were of type int, no special declarations were required. You didn't have to enter them all in a header file. The Miranda software contains 500 or 600 functions split between a dozen files. So what do we have to change to meet the modern C standard? I put at the bottom a list of the C standards. The 1990 standard, which was the first cleanup of Kernighan and Ritchie C, is still backwards compatible. It introduces some good things like type void and prototypes, which it borrowed from C++, but none of this was compulsory. It was still backwards compatible with K and R C. It was only in 1999 that the implicit int rule was dropped. Anyway, so what do we have to do to meet the modern C standard? We have to, taking this same piece of code again, we have to put function prototypes for foo and bar at the top or in a header file that's included at the top, which gives their full types. You have to say that they're of type int, you have to say what the parameter types are, and bar is declared to be of type void, and it has no parameters. That's also checked, which is why I say void up here. So C90 was my starting point for the conversion. So why was everything int in Miranda? It isn't now, by the way, I had to change that. Why everything was int was I had this scheme which I was quite pleased of at the time I invented it. Miranda values, there's a number called atom limit, which is about 1,000. It gets generated by the make file. Integers below atom limit represent atomic values. For example, Latin 1 characters, combinators, which are very simple atomic functions, and miscellaneous atoms like nil. And all other Miranda values are stored in the heap. They are boxed, as people say now. And they are also integers, and the integer is the offset into the heap of the leading node of the object, which and nodes have a head and a tail field and a tag field. Of the 8-bit tag, 1 bit was used by the garbage collector for marking, but that leaves you 7 bits to describe the different possible types of node. And nodes were used for compile time objects like lambda expressions as well as runtime objects. you've got 127 possible node types. That's quite generous. I was never used more than about 12 of them. So everything's an integer. Integers below atom limit are atoms. Integers above atom limit are pointers into the heap. And the heap vector was biased so that it didn't start at 0, it started at atom limit. It was offset, I think is the word you would use. I will say a word at this point about the garbage collector. The garbage collector was a so-called conservative collector. It scans the C, oh, it still is, it scans the C stack looking for heap pointers to follow. How does it know if it's a heap pointer? Well, if the number is in range and that point in the heap has a sensible looking tag, then it assumes it is indeed a heap pointer. So you might be marking some things that are actually garbage and didn't need to be marked, but that is harmless as long as you do mark everything that does need to be marked. However, on a modern optimizing compiler, this is a bit fragile because an aggressive compiler optimization may hide in registers things that you thought were on the stack. So when running Miranda now, it is often necessary to turn off -o in the compiler, so it compiles without optimizations so that the garbage collector can work. And if you download Miranda to use it, there is a README file that tells you about that and other things you need to be aware of. So here is a quick overview of the Miranda system. It consists of, I think well, altogether there were about 12, but here are the main segments of C code. At the bottom row, we have the compiler, a Lex analyzer, which feeds lexemes to a YAC program with semantic actions in C that emit abstract syntax based on lambda calculus with lambda expressions, let and letrec blocks, and list comprehensions are still present at this stage because it's better to keep them whole until after type checking. Only then will they be transformed out. And then this abstract syntax tree is fed to the type checker, which does Hindley-Milner type checking, slightly extended version with polymorphic type recursion. And then the same same syntax tree of lambda expressions comes out the other end, but now the identifiers are labeled with their types. And then it goes to the translator, which generates SK combinator code, and list comprehensions are generated to SK code at this stage. And then you have a combinator graph reducer, which works in conjunction with a big integer package because Miranda has a single arithmetic type called num, which has both unbounded precision integers and double precision floating point with free conversion between them. And in charge of the heap is the heap manager, and that does garbage collection when necessary. And of course, there's a make file which puts the whole thing together when you compile it, and various header files. Right, the first thing I did was to make sure that my 11,500 lines of 1980 C would compile to the C90 standard, and this is the incantation that you say with GCC. I alternated between GCC and Clang, which have slightly different properties. Clang produces better code. It also produces a huge number of warning messages, most of which I had to turn off because they were warning me about things I didn't want to know about, like telling me how to write nested if functions. Well, I already know that. And I spent quite a long time studying the error messages from Clang to find out which ones to turn on. And to cater for the fact that I have at this stage no void declarations, I had to say this, -w no return type. And then with that incantation, Clang was able to compile it. was able to compile Kernighan and Ritchie C. So this is my starting point. It's at the Miranda website, miranda.org.uk. If you want to download the 32-bit code, it does still work on Linux. But anyway, let's go on and see how I changed it. My first thought for changing to the modern standard was that I would go through all 11,500 lines of code, line by line, making changes manually based on my understanding of the semantics. Well, I soon realized that that was not a very good idea. Going through 12,000 lines of code manually, I'd be bound to make hundreds of mistakes. And the other problem is that if you're looking at code that you wrote 30 years ago, it's code written by someone else. You no longer understand it. After working with the code for weeks, a lot of my understanding came back to me, but initially I was looking at code that effectively had been written by someone else. So I had to work on the syntax, not on the semantics. I worked in small steps, largely automated, writing automated scripts, sometimes editor scripts, sometimes written in Miranda, to go through the code and make systematic changes, not understanding it, but just changing the syntax from Kernighan and Ritchie C to whatever is required in the modern C standard. And the other kind of changes I did were guided by error messages from the compiler, which gave me the line numbers of particular kinds of error. For example, assigning things to an integer of the wrong type and so on. So here in a bit more detail are the steps that I undertook. And this was several months' work. I started this in October of 2019, and it wasn't finished until January of this year. The first step was to get rid of int. So I placed a type def at the top of my main header file, defining a new type word as int, type def int word. And then I wrote a script to change every int declaration to a word declaration. And then I wrote another script, both of these scripts were in Miranda, by the way, to insert word before every untyped function definition. Now, some of those would have been void, but I started by making them all word, and remember that word still means int at this stage. Then I got the compiler to give me all the error messages where int should have been void, and I went through manually and changed word to void at all those line numbers. Now, the next two steps were more tricky and actually took several weeks. I found a way to trick the make file into listing for each .o file all of the functions defined in that .o file which are required by other code segments. And that's by fiddling with the link line to leave out each one .o file at a time and collect all the error messages. So that tells me where I have to put prototypes, which prototypes I have to put into header files and which header file they have to go into. And then I did a similar thing using GCC or Clang, I forget which now, to find all the places where functions are called earlier in the script, earlier in the program than their definitions. And all these are going to need prototypes. And it tells me where I have to put them, which is in that file. Altogether, these two steps gave me 293 function prototypes to write. And I spent quite a long time organizing this into files grouped by type and by file of origin and file of destination. As I said, it was at least a month's work. But at the end of it, I had all my function prototypes in the right place. And lo and behold, I was able to compile it without the standard equals C90 flag. So it's now in 2011 C, but it's still 32 bits. Right, so the last stage is to convert to 64-bit code. So what I did was I changed the definition of word from int to long. So it's now type def long word. Why is that clever? It's clever because long means 32-bit word on a 32-bit machine and a 64-bit word on a 64-bit machine. It means whatever is the natural word length on this platform. So what I'm aiming for here is to have code that will compile on a 32-bit platform or on a 64-bit platform without changing anything in the code. So the first step was to change word to long, and then use the compiler to find all the places where long shouldn't have been long, should have been int, because my system calls, POSIX system calls, if the POSIX header says it should be an int, the compiler will squeak if I pass it a long, because even if long and int happen to be the same on this machine, the compiler knows they're different in principle. And then I also used this flag in GCC, Clang has the same flag, to find out all the places where I had to change the format strings, because the Miranda code has hundreds and hundreds of print statements for error messages and all kinds, and the normal functioning of the system. So that was quite a bit of work. And then I did lots of consistency checks. For example, collecting all the external scalar definitions from all the C segments into one giant file and sorting them and checking for consistency. And lo and behold, I found at least a dozen scalars that I had declared with two different types in different places in the code. So cleaned all that up. And then I removed minus M32 from the C flags. So that's jumping in at the deep end. Did everything work immediately? Well, no, but it was maybe half a dozen errors I had to fix. It was astonishing how little went wrong. And so I now had code that compiles on both 32-bit and 64-bit platforms using the same code, except for one place, which I'll show you in a minute. Almost all of the work was done by defining word to be long. So the source code for this ambidextrous 32-bit or 64-bit version of Miranda is at miranda.org.uk. Downloads, if you are interested, please download it and send me any reports if things go wrong. So what was the one place in the code where I couldn't just rely on long? We have two possible definitions, two possible versions of the Miranda heap. In one of them, head and tail are 32-bit words. In the other one, head and tail are 64-bit words. The critical case is when I want to store a 64-bit float into the heap. That's one of the things I have to do in my data structures. Well, on a 32-bit machine, I have to split the 64-bit float into a right and left half and store them in the head and the tail. That's what this bit of code is doing. And on a 64-bit machine, I can just stick the whole 64-bit number into the head field. And this is a compiler switch based on word size. This is the only place in the code where I explicitly test the word length. And while I was preparing this lecture, I thought of a way to get rid of this, which might appear in the next version. Right, so having got Miranda to run on modern machines, what am I going to do with it now it's alive again? Well, here's a sketch of what I'm planning to do. Some of this work is already underway. The first thing is, if I commit myself to 64-bit machines, and that's clearly the way to go, I can rewrite the SK reducer and, more importantly, the garbage collector to make use of the fact that I have 64-bit code. It means I don't need the tag field anymore. There's enough bits in a pointer to put the tags into the pointer. That's more efficient, and I can also have a more robust garbage collector that does not depend on scanning the C stack. I've already written this improved SK reducer and garbage collector. They're not quite ready for prime time yet, so I haven't released them. Large parts of the system can be rewritten in Miranda. What I have got is a Miranda equivalent of YAC that works seamlessly with the Miranda type checker. And what I haven't done and will do, I've done bits of, is rewrite all of the Miranda compiler in Miranda, which will make it much smaller. And the session manager can also be written in Miranda. This steer point C interacts with the user, loads and unloads files. It's the session manager and does overall control. All of that can be written in Miranda, given a few hooks to get access to system functions. So what remains in C is the heap manager and the SK reducer and the big integer package. And I probably ought to throw away my big integer package that I wrote in 1987 and use GMP instead, which will be a lot more efficient than my homegrown effort. Right, the other thing I'm interested in doing is if I make some quite simple lexical changes to Miranda, it becomes much closer to Haskell. The two languages are very close anyway, but for example, changing my type names to uppercase liberates lowercase variables to be type variables, which is what Haskell does. And so I can get rid of my rather clumsy use of stars as type variables. Okay, so then why would anyone want to use Miranda, assuming I do this to it, rather than Haskell? Well, it's a much smaller language with a less steep learning curve. It has a simpler type system because it's just, there are no type classes. Type classes are incredibly powerful and very clever, but they greatly increase the complexity of the type system. And I think there is a value in having something rather similar to Haskell, but without any type classes, which is basically what Miranda is. It also has much simpler arithmetic. As I mentioned before, it has a single number, a single type num, which includes unbounded size integers and double precision floating point with free conversion between them as needed, which is very convenient for beginners. So I think Miranda has some life in it as a language that people could use to teach themselves functional programming in a style very, very similar to Haskell on something that's easier to learn, and then switch to Haskell later when they want a compiled language. So I think it still has life in it. I would encourage people who are interested to download the Miranda system from the website, miranda.org.uk, and let me know if there's anything wrong. You can add yourself to the mailing list, and then you will get informed when, I think I'll have to call it Miranda 2, because it's going to have a slightly different syntax when Miranda 2 comes along. So I hope some of you will try this out. I look forward to hearing from you. And I think Herb now wants me to stop to give time for questions. So do I switch off the screen share at this point? I think I do. Yes, and now I think Herb takes over again. Is that right?
Indeed he does. Hang on, he's fiddling with his interface as well. Oh. There we go, under more somewhere.
I'm still here, but I'm waiting for Herb.
I'm here, can you hear me?
Yes, I can't see you.
Ah, yes, I'm fiddling with things here. God, yeah.
Was my timing all right? I think that was half an hour.
No. I think your timing was incredible. Here we go. So thank you so much, David. Looking at the comments, I'm looking for questions, but so one that I had was, given that there was a little ecosystem around Miranda when it was released earlier, what type of systems do you think might be revived now that we have another go at it on modern systems? What are the things you're most looking forward to seeing again?
Oh, well, the program development environment, or whatever you call it, comes with Miranda, and it's still there. It's there's an online manual. I might change that because the pages are all in text. They ought to be in something more civilized like HTML or PDF. But the way you interact with the system will remain very much the same. I mean, it's like GHCI or Hugs. I mean, Miranda had that kind of environment anyway, and I'll keep it.
Sure.
Yeah, so that won't change.
And
I rewrite it in Miranda.
sure. So I imagine there would have been some changes around kind of connectivity and libraries for kind of sharing data over kind of sockets or connections like that. What kind of updates can you see happening in the near future once the community kind of gets a go at it?
I don't know. I think if well, actually, already more than 1,000 people have downloaded the 64-bit Miranda. I haven't changed the syntax yet. It's still the original Miranda, but now running on 64-bit platforms. And I've got hundreds of names on the mailing list. So I think if I start doing new things, people will hopefully try them out and make suggestions. So I'm very happy to be guided by a user community if one arises. And of course, because it's open source, people can change things themselves. I ought to put it on GitHub. I have got a GitHub account now, but I don't really understand Git very well yet. So I haven't actually put the software on GitHub. I ought to do that, and then people can send me, are they called push requests or pull requests, whatever? I don't know the terminology yet.
Oh, yes.
But Richard Carlson has been nagging me to use Git for a couple of years, and I will actually start doing it soon.
So maybe that's the first thing, a Git tutorial for Miranda. You've done a kind of a textbook open sourcing, and maybe there's a little tutorial in how you kind of put it in the main ecosystem.
Right.
Have we got some more questions? Anything anyone would like to ask? A lot of you have this ponderous face. This, I'll think about it, and I'll see.
Yes, I could ask myself a question. I'm just wondering what. Yes. What I was going to think. Yeah, what is the best thing about Haskell that Miranda didn't get right? And I'm going to. It's something really trivial, and that is using lowercase identifiers for type variables and uppercase identifiers for type names. I had what I copied from the original ML. This was before, when I was designing Miranda, it was before standard ML came along. I used star, 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 and so on as my alphabet of type variables. And once you get up to about 6 type variables, it's incredibly clumsy. So although it's an incredibly simple thing, that was what I liked most about Haskell. I was never quite sure about the type classes. They're incredibly powerful, but a bit frightening. So I'm quite happy that Miranda still doesn't have type